Aki, could you face mute? Okay, and then let me just do a very quick intro and then we go,
Sure.
Are we live? No.
Yep, go for it.
Good afternoon, good evening, good morning, tech speakers. It's Wednesday, February 14th in California, and it's Thursday, February 15th in the morning in Singapore, where I'm really delighted to introduce Hui Jing Chen, or Chen Hui Jing, who will talk to us today about modern layouts with CSS Grid. Jing, let me turn the floor over to you, and I will face mute. We'll be back in about a half an hour, plus or minus, to take your questions. The link to the Etherpad can be found in your invite and in the Telegram channel, and look forward to hearing from you with questions at the end of Jing's talk. Thank you.
Thank you, Javi. So, hello everyone. This is my first time doing a talk via video conference, so it will be interesting. So like as Javi said, my name is Hui Jing, and I'm a front-end developer based in Singapore at the moment. And today I'll be talking about CSS Grid and why it's a milestone for web design. So these CSS-related memes have been going around for some time, usually accompanied by some joke about the deficiencies of CSS, or the cascade, or how impossible it is to manage. Well, I disagree with that notion. You see, I love CSS. I love CSS for what it is and what it can do. So today I'll be putting forth some ideas that you may not entirely agree with, but I do hope you will hear me out. Let me start off with a short story about the web. The World Wide Web was invented by Sir Tim Berners-Lee in 1989 as a means for researchers to share information. Now back then, CERN had a problem with information access, and his paper introduced the concept of linked information. So it would be possible to cross-reference information held electronically on machines across the world, creating a web of information via some form of hypertext. And when the web started, there was no way to do layout at all, because all browsers could do was display text, or maybe some images if you were lucky. But as more users started getting online, people started to find new ways to utilize the web and design for it. So properties that were never meant to be used for layout, like HTML tables or floats, were the next best hack we could think of. Eventually, this got really painful, and people started relying on frameworks to do the heavy lifting, especially when it comes to the layout side of things. In fact, I've inherited a lot of legacy projects that include the entire Bootstrap library but only use its grid system. So this is a general overview of how web layouts have evolved over the years. Now CSS Grid gives us a level of control over how elements are rendered on a page that we've never had before. And that's the biggest reason why it's revolutionary. Now CSS Grid, I feel, had one of the best rollouts of a new major CSS feature ever, with almost all the major browsers shipping it in March last year. By now, more than 70% of the market is using a browser that supports Grid. All the other techniques we've used in the past, HTML tables, floats, even Flexbox, were never meant for doing full-page layouts. They were creative hacks we came up with to build the layouts that we wanted. So now we actually have proper layout properties like Flexbox and Grid. And when we use them in combination with other properties like CSS shapes, transforms, viewport units, and so on, the design possibilities become endless. Now my love for CSS is inordinate enough for me to read specifications. Honestly, they're not that bad to read. Now CSS first became a W3C recommendation in '96, and it used to be a huge monolithic document. In 2000, a decision was made to modularize the specification, which made it easier to update and support. As of the 2017 snapshot, there are 88 modules in various states of development. Browser vendors refer to these specifications to implement features into the browsers we use. Now, despite modularization, CSS is ultimately a holistic technology, in that even though you can use properties in isolation, the full power of CSS shines through when used in combination. CSS is a team sport. For example, Doing layout on the web usually starts off with using the display property, but we definitely use a whole suite of properties that number more than players on a basketball team. And some people have asked, why do we need grid when we already have Flexbox? Or is grid supposed to replace Flexbox? My response is, these two layout techniques are not competing against each other. They're meant to be complementary. Grid and Flexbox are best friends, like bacon and eggs, like nuts and bolts, like Jay-Z and Beyonce. Either are good on their own, but together they can reach another level of awesome. Now, Flexbox is suited for laying out items in a single dimension, where there isn't a relationship between the rows and the columns. Think of it more like a long daisy chain of Flex children. Now let's examine CSS Grid. What exactly is it? This is how it's described in the specification, and the keyword here is two-dimensional. So keep this in mind for the rest of the talk. So there are a number of terms I will constantly refer to throughout this talk, so let's make sure everyone is on the same page. I'm sorry that the slide is a little bit cut off, but you can see everything. Grid lines are the horizontal and vertical lines that form the basis of a grid structure and can be referred to by their numerical index, which starts from 1. Now each space between the grid lines are known as grid tracks, which make up the rows and columns of the grid and represent spaces that your items will appear in. The grid cell is a single unit of the grid and is made up of 2 adjacent row lines and 2 adjacent column lines. By default, each grid item will take up 1 grid cell, and a grid area is simply made up of multiple grid cells. Now the best part about grid is the ability to define grid gaps, which are the gutters between grid tracks. Fun fact, grid gap wasn't in the original specification until Rachel Andrew championed it during one of her conference talks, and one of the specification writers, Elika Atamat, was in the audience, and they worked together to get this feature into the specification. So the next time you use grid gap, remember you have Rachel and Elika to thank for this excellent feature. Now the first concept to wrap our heads around is the fact that grid, like Flexbox, operates on a parent-child relationship whereby the display property is set on the parent element, and this then affects the layout of all the immediate children of that element. Now my favorite way of explaining the CSS Grid mental model comes from Rachel Andrew, who describes this as such. Grid works from the container in, while all the other layout techniques start from the item first. So let's illustrate this with some simple examples, which will also serve as the introduction to the most basic setup for using CSS Grid. So the setup here is 6 items we want to place in a 3-column grid. One approach for creating such a layout is by using the inline block technique, as you can see in the code. For a 3-column grid, we set the display of the items to inline block and give them all a width of 1/3 of the container. It's almost exactly the same if you use float, because you also need to set a width on each item. For Flexbox, to ensure our items line up in 3 columns, we have to make sure that the flex basis is again 1/3 of the container. The properties we're applying still go onto the item. And for all the 3 techniques I just described, there isn't actually a grid. It just looks that way because we forced the items to line up with each other. But for grid, the dimensions for rows and columns are defined on the parent container instead. So the grid is real. Now before CSS Grid, we've always tried to size our elements as best we could, then crossed our fingers and hoped the browser would render them in the right place. But now with Grid, we can control exactly where our elements should go. The basic premise of how Grid works involves 2 steps. You define the grid, and then you place items in it, either by yourself or you let the browser do it for you. So let's look at the properties that are applied to the grid container first, which will determine the size and structure of the grid we want to create. Now there are numerous values we can use to define the size of our grids, and there are those which are familiar, like fixed units of pixels or ems. There are also relative units like percentages or viewport units. And we now also have a new flexible unit known as FR, or fractional unit, which I will cover in more detail later. So the key properties to define a grid are grid template columns. So for this example, we'll just use a simple 153 column layout. And the next property is grid template rows. So it's really straightforward, and the code itself is very visual because you can see that there are 3 columns and that there are 2 rows. And to define gutters between the items, we use, as mentioned previously, grid gap. And these 3 properties are essentially enough for you to get started with creating using CSS Grid. Now, one thing I'd like to remind everybody is that the web is not a static medium. It is dynamic and interactive, and we manipulate this medium by writing code to tell the browser what we want it to do. So here's an idea. Instead of micromanaging the pixels on our designs, why not let the browser do its own thing? This means being okay with your designs looking different across browsers and devices. But is that really such a bad thing? We now have an increasing number of properties and values that pass on the responsibility of figuring out sizing to the browser. One of them is the FR unit, which represents a fraction of free space available. So a common use case that FR units can solve for is for responsive uniform grids that need to adjust to the width of the viewport. So for layout methods that revolve around the width of the grid item, multiple media queries are necessary because the width of each item has to be explicitly stated depending on the width of the viewport. But with this new FR unit, we're essentially ceding control of the sizing of each grid item to the browser, allowing the browser to figure out how large each grid item should be based on the parameters we provide through some new functions that CSS Grid introduces. So in this example, I'm telling the browser that I want 3 sets of 2 columns in the ratio of 3:2. Now, by using the FR unit, all the available space is divided up accordingly. The grid then grows and shrinks together with the viewport because it will occupy all the free space available in the container. So you'll notice that I used a function in the grid template columns property, which I will cover later. One of the new functions that CSS Grid gives us is the min-max function. This function allows us to do something that we never could before, which is to define a range of values. So now I can actually tell the browser that I want my grid columns or rows to be between a value of X and Y, and the browser can figure out exactly what that value should be. Also, if your design calls for a rather complex and large grid, you probably don't want to type out each track's width by hand. The repeat function allows us to repeat patterns of track sizes so we won't end up with ridiculously long lines of column or row sizes. Now, the repeat function also takes in the keywords of autofit and autofill, which are very similar. Both these keywords tell the browser to generate the number of tracks required based on the track list specified as the second argument. Now, a minor difference is that for autofit, the empty tracks are collapsed, and this will become more evident if you're using a flexible range for track sizing. In this example, I've asked the browser to make me columns that are at least 100 pixels wide, but can grow as free space permits. So even though right now I only have 6 grid items, the columns are actually still there if I use autofill. So there's this white space because there are 2 columns that are not filled by grid items. If I change this value to autofit, the last 2 columns are collapsed, and the columns that do contain grid items will grow to fill up the empty space. So this is something to keep in mind when you need to design a layout. Now for this example, I'm telling the browser that when the viewport size shrinks, I want to cap the shrink of each column at 10 ems, but if there's extra space, grow all my columns equally. So by using autofill or autofit, the browser will calculate how many columns fulfill my requirement. And when the viewport size changes, the number of columns will decrease or increase until everything fits. Because the maximum value is a flexible unit, if there's an excess of space, like maybe there's 6 ems of space left over, all the columns will grow equally to fill up this extra 6 ems. So, and not a single media query was needed to get this sort of a presentation. And you might have noticed that although I explained each feature individually, they're so much more useful when used in combination. Team sport, remember? One more thing I want to mention is the concept of an implicit grid. The explicit grid is one where we define using the grid template columns and grid template rows properties. But there's nothing stopping us from placing an item outside the bounds of this grid. What happens then? In the simple 3x2 grid, the grid column lines only go up to 4. But if we place an item starting on grid line number 5, the browser will add 2 implicit columns as shown by the purple dashed lines on the grid to accommodate this item. It's really a very smart algorithm. Next up is alignment. Because aligning stuff on a page is practically the most important part of building web layouts. And box alignment is a topic that can sometimes trip people up. I know it can be hard to remember exactly which property does what. So for me, I associate justify with the direction that text flows because I've been justifying text in Microsoft Word since version 97. And if justify is for the inline direction, then it makes sense that align must be for the other direction. So directions to me are not the most tricky part. It seems that it's the second word in these properties, content, item, self, that seem to confuse people. So this table summarizes the 6 box alignment properties that are regularly used when building with Flexbox and Grid. The justify content and align content properties are known as content distribution properties. These properties are relevant when the container is larger than the total width or height of the grid rows and columns. So as we can see from this particular example, there is some space to the right and to the bottom of the grid items, and it is possible to set the alignment of the rows and columns with respect to the entire grid container. So there are 3 values we can use: start, which is the default, center, and end. So these will shift the rows and columns along the respective axes. But we can also adjust the space between rows and columns using space around, space between, and space evenly. So it's probably easier to refer to this table. And as you can see, space around puts an equal amount of space on both sides of the row or column. So the spaces at the edge of the container will be half of the spaces between the inner rows or columns. Now, space between distributes all the tracks evenly within the grid container, with the first and last rows or columns flush with the edges of the container. And space evenly is currently only supported in Chrome 60 onwards and Firefox 52 onwards, and it distributes the grid tracks evenly within the grid container such that the space between any 2 adjacent grid tracks are exactly the same. If everybody is completely lost now, please trust me when I say it gets easier with experience. Now, the justify self and align self properties are known as self-alignment properties. So justify is for the main or inline axis, which is the direction of text flow, while align is for the cross or block axis, which is the direction that block boxes are stacked. So these properties allow us to control how the content of each grid item is aligned within the grid area it's been allocated to. The default state is stretch, as you can see in item A here, where the content stretches to fill the entire grid area. And we can adjust the alignment of content within the grid item with start, center, or end. The moment you apply a start, center, or end value to the align or justify self property, the entire grid item will shrink to fit the contents. So finally, we have align items and justify items. And these properties set the default align self and justify self behavior of all the items within the grid. So it's essentially just a mass setting of the justify or align self properties. So let's do this. And you can see as everything shrinks to fit the content. So early on, I mentioned that Flexbox and Grid work really well together, and I want to share an example of that. So the image on the left is a page from the publication Mallory Photography, filmed by Laszlo Molinaj, who was a professor at the Bauhaus School. Now, the layout is made up of several striking, thick black borders around each grid cell. Each cell also contains a different type of content, and their alignment varies from cell to cell. So how would we recreate this and align things according to the original design? When I first started building this out, my first instinct was to use the justify self and align self properties to adjust the content positions. Nice try, but it was a no-go because the border property applies onto the grid item. Any grid alignment property other than stretch makes the size of the grid item fit to its contents. So any borders applied to the grid items naturally fit the grid item's contents. So it sort of messed up my design. But if we instead apply display flex onto the grid item, we can now use flex alignment properties applied onto the flex container to position the grid item's content accordingly. Remember, awesome together. Now the next thing we're going to cover is the manual placement of grid items. And when it comes to grid placement, my mind instinctively draws a parallel with placing pieces on a chessboard. Other than using a numerical index to refer to specific grid lines, we can give them names as well. Now line names can be any string except span, which is a keyword. And there's no limit to how many names you can assign to a particular line either. Another handy feature with grid lines is a negative index. So this means that if you need to refer to the last grid line and you don't know how many grid lines there are going to be, you can always use -1 to get at the last grid line. So say I want something to go into the big main area in this example, I would set both the grid row and grid column properties to either 2/3 or use their line names of content start / content end. So we can see how this works. Grid row and grid column are actually shorthand for their respective start and end properties. So by default, each grid item takes up one grid cell. So in this example, I've only put in one value for each of the grid column and grid rows property. So the start position for everybody is just one grid cell. And of course, I can make a grid item span multiple rows or columns by specifying an end value. So let's just take the third child, which is probably the coconut. I can make it span multiple grid cells. So the code is pretty intuitive. And if you notice, it's actually possible for grid items to overlap each other as well. And this will be covered in a later example. So while we're at the topic of naming things, I want to point out that we can also name grid areas. So the syntax of the grid template areas property provides a visualization of the structure of the grid, making the overall layout of the grid container much easier to understand from a code perspective. And we then place items in their respective areas by assigning the grid area property onto the item. So again, you can see, although it's a little bit cut off in this diagram, the logo, stats, score, and the board, they all correspond to how it looks like in the code. So this is an example of how grid areas can be used when you are even planning a layout. So the dot notation in my code just indicates that, it's empty space. But let's say I want item A to take up, to be a bit bigger. I can just manipulate the grid template areas property without touching the grid items themselves. So this makes adjusting the layout at different contexts a lot easier. So there are a few graphic design concepts that we can now do on the web because of CSS Grid. And one of them is vertical white space. Now, vertical white space is an important concept in layout design because it serves to balance the layout and bring focus to important content. So before CSS Grid, trying to do this on the web involved hacks like spacer gifs, empty divs, JavaScript, you name it. That's because there was never a proper way to lay out things on the web other than one after another. I mean, you could use absolute positioning, but that sort of opens up another can of worms because now you're messing with the document flow. But life's different now. It's better with CSS Grid. So with grid template areas, creating responsive layouts becomes a little more convenient as well. So right here, I have a recreation of a Braun hi-fi print poster, which was originally laid out in landscape. But on the web, this same layout would break if the viewport starts to narrow. So we'll need to adjust the layout when that happens. Now, by using the grid template areas property, handling responsiveness becomes much easier than traditional techniques. So this is how we modify the layout by changing the grid itself. So I'm not sure if you can see very clearly, but because I'm using Firefox, and Firefox DevTools actually allows you to display the grid area names, you can see that I've assigned each section its own named grid area. And when the layout is too narrow for the original wide design, I don't change the sizing of the items. Instead, I actually change the grid itself. So when it hits yet another breakpoint, the grid gets morphed once again. So I find this approach to be a rather convenient solution for a relatively common use case. Okay, so this is the final end result, and you can see how the layout changes with the viewport. Now I'm going to make an assumption here that most people have used media queries in some capacity before, or at least seen one. And the most common media queries are width-based. And occasionally you may see a height-based media query or two, but there are a lot more media queries out there that I don't often see people using. So in the current specification, there are 13 media features that can be used as conditionals, including things like orientation, color, resolution, and so on. Now, this particular design I'm showing in this demo is a very good use case for the aspect ratio media query. So aspect ratio media queries come in really handy when relative proportions are important for your layout. And we can always combine multiple media queries to cater for different environments. So another technique that makes layout interesting is the use of overlap, because it breaks our expectation of regularity in a grid. But we don't usually see overlap on the web because it used to involve a lot of tricky positioning rules and negative margins. Some people just cheated by processing everything into one single image. No. I've also seen solutions that use JavaScript to calculate the exact positioning. But we don't have to do all that anymore. So here's a simple example of overlap, just two circles behind a header. So the code here is already simplified to show only the placement properties. Pseudo elements are treated as children of a parent container. So these two circles, the red and green circles, are pseudo elements of the grid container that had been explicitly placed to overlap. And the header simply overlaps the both of them. So this placement code is a lot more intuitive than using absolute positioning, and you don't need to do a lot of complicated math just to get the alignment right, regardless of how the browser is resized. So I'm going to go through a really high-level walkthrough of how I would build a grid layout with overlaps from scratch. So I saw this. This is an artist concept on Dribble for the musical band Typo. And the way it's been designed, I feel, makes it a perfect candidate for CSS Grid. So one thing I noticed after I started building the CSS Grid is that I would sketch my designs on pencil and paper a lot more. Because for Grid, you have to plan the entirety of the layout beforehand. So it definitely helps to have the big picture view in your mind up front. And by sketching it out, it also helps me think about how the track sizing should be done. Which tracks should be flexible, which should have a defined width, or perhaps some tracks need to have a range of widths. And yes, it is a bit more thinking and planning up front than before, but the end result is also much nicer. So to me, markup always comes first. I'll start off with every element that needs to be displayed, title, bits of text, an image, so on. And then, based on the design, we'll add in some base styles. Nothing amazing, just the fonts, colors, text formatting. So browsers do apply their own styles, so usually I'll just reset the margins and paddings and set box sizing for all elements to border box. Just very, very basic resets. So I've been going on for quite a bit now. And even if you think whatever I've been saying up to this point is totally boring and doesn't benefit your life in any way at all, I really want you to remember this point. Websites do not have to look the same in every browser. Because the web is not static. It is up to the people like us who create things on the web to change people's mindsets. Okay, the uninterested people can go back to being bored now, as I continue. Now, I did not put in that slide as a time marker. The point I was trying to make is that rather than spending extra effort wrangling every pixel into place, why not embrace the dynamism of the web? The best part about the web medium is its ability to layer on additional functionality depending on the browser on which your page is being rendered. Now, I genuinely believe that web pages don't need to look exactly the same across every browser or device, but I do believe that no layout should be broken. So the base layout should utilize properties that almost have full support. So in this particular example, I'm really just letting everything stack on top of each other with some minor positioning at the bottom. So browsers that do not support grid or feature queries will get this layout. Now comes the actual grid code. So I chose to go with flexible units like FR and viewport units because I wanted the layout to fully occupy the window without overflowing when space allowed. So if you look at my grid template columns property, it does look a little bit nuts if you've never used grid before, but once you start experimenting with the different functions and values, I promise this will make sense to you. So I have a friend who does web VR, and he once said that until you put on the headset, you don't really know VR. This is somewhat similar. You need to feel the grid to understand it. So this is how the whole thing looks once we do that, when we do the developer thing of resizing the browser window all over the place. My video's not playing. Here we go. So you can see how the design morphs as the viewport size changes. And I have been informed by non-web developer friends that this resizing is not normal behavior. I'll just look at them like, what do you mean? You don't resize your browser 1,000 times a day. Anyway, moving on. So some of you might have noticed that my grid code was wrapped within an additional query with the syntax @ supports. This is otherwise known as feature queries, and they're defined as such, conditionals that test if the browser supports a particular CSS feature. So this is how a feature query looks like. The conditional checks if the browser supports a particular property or not. Now, if it doesn't, the entire block within the @ supports rule is ignored. So this means we start off with a basic layout that works everywhere. It could be flexbox based, even single column with largely browser default UI elements, that sort of thing. And then we layer on styles based on the features that we want to use, like what we saw in the previous example. So by organizing our code in this manner, the browsers that do not support feature queries or the specified property will still get styled, but those that do get a different look. So we're making use of the C in CSS. So you can call it cascading web design. If this concept ever takes off, remember, you heard it here first. Now, support for feature queries is really good, with coverage in over 90% of browsers, including Opera Mini. But you might have noticed that Internet Explorer does not, and in fact will not ever get it. So here's where a decision has to be made, and it will differ from project to project on whether it is acceptable to forego some of the features that IE11 does offer and serve up a more basic fallback instead. Again, there is no definitive answer to this until a proper discussion with relevant stakeholders arrives at an acceptable conclusion. So this next example is a header design, and I got it from a CSS Tricks article. And since it was originally an image anyway, you can think of this as an enhancement. So the fallback code here serves up an image, which is actually the original image used on the site. So the message in red is just there to show that this particular browser, which is IE8, does not support CSS Grid or Flexbox. So essentially, this is the fallback that all browsers will get regardless of whatever it supports, which is the image. But let's say I have a browser that supports Flexbox. So this feature query is for browsers that support both Flexbox and feature queries, but not Grid yet. So they'll just end up with basic styles that look like this, with all the benefits of searchable and indexable text, because everything in this particular header is written in HTML and CSS. So there will be some resetting needed as we layer on different features based on feature queries, and fully understanding the cascade is a prerequisite for embracing this sort of a design approach. So this second feature query is for the latest browsers that support all the things. So this particular layout's use of vertical white space, the need to maintain alignment of its individual elements as the viewport changes, makes it a perfect candidate for CSS Grid. So this is the second block that will appear in my code. So this example just shows us that we can now write code that is not browser specific, but feature specific, which means that we don't have to keep revisiting our code every time the browser updates. The design updates itself together with the browser. I mean, how cool is that? So Daniel Huntrots from ClearLeft said it best. CSS has its own unique landscape and structures, and our mental maps around it need to reflect that. So Jen Simmons and Rachel Andrew have done a lot both for developing layout on the web as well as educating the web development community about it. So Rachel Andrews has a CSS layout course which is completely online, while Jen Simmons has a wonderful collection of demos which you can check out. And I think everyone should build up their own collection of demos because that's the best way to learn and familiarize ourselves with CSS in general. So this is the list of standalone demos and sites I've referenced throughout this talk. And if you're interested in the source code, my demos are all hosted on GitHub, which is the last link on the list. And this is a list of relevant articles and resources that I found really useful for better understanding CSS Grid. Thank you all for your time and attention this evening. Back to you, Javi.
That was awesome. That was a really, really top-notch talk and full of useful information. I don't think we've put the slide deck link into the Etherpad yet, but I'll do that if that's okay with you.
Sure.
Okay, cool. I see it at the bottom.
It to you?
Yeah, if you wanted to pop it over on Slack, I'll
Okay.
add it to the Etherpad. We do have some questions that arrived in the Etherpad during your talk, so there's live viewers. I know I was feeling like I wanted to let you know that there were people engaged while you were speaking because I feel like it might be lonely talking to your camera. But so I'll start with some of the questions on the Etherpad. I'll start at the bottom and work my way up. So a question came in from the channel. Does the complexity of the grid have a significant impact on website performance?
I don't believe so, simply because the browsers that do support grid are the more modern browsers. And for example, if we take Firefox, Firefox has already rewritten its engine to use Quantum. So even, I think modern browsers that do support grid at this point are already optimized to a point where a complex grid is not going to be the bottleneck that impacts your website performance.
Cool.
Yeah.
So yeah, and I bet there's I bet a performance engineer would have a different perspective on that as well.
Probably.
But that's a topic for another talk. So moving right along, there was a question from Daniele, who's a web developer in Italy, and actually a pair of questions. So he asks, is there a problem of CSS compatibility between browsers like there was a few years ago? I think you kind of covered that, so I'm going to pair these two questions and maybe you could speak to both of them. The next one is, what is the most missing feature, or what's the thing that you find missing still in CSS, I think, that you would most like to see implemented? So kind of how the different browsers handle, and what's the missing thing that's top of mind for you now?
Well, for me, I'm thinking, well, off the top of my head, because I do a lot of things with relevant to vertical writing. So there's this one particular feature. It's not exactly a CSS thing, more of a probably an HTML thing. But I was thinking it would be nice to have a media query for writing mode. But back to his original question of the problem of CSS compatibility, I feel that is solved, not completely, but reasonably, with feature queries, because you sort of are able to target specific features, as opposed to in the past, the problem of CSS compatibility came about when people kept writing code that targeted specific browsers. So your code wouldn't work across different browsers. But now with feature queries, it doesn't really matter if whichever browser is reading your code, because if it doesn't support a particular feature, then it's fine. It won't break. It'll just ignore the block. So I think feature queries is one of the, I would say, groundbreaking changes that we have in terms of trying to have CSS compatibility. And that also ties back into the point that I was trying so hard to push, that websites don't have to look the same in every browser. Because this is the only medium that we have in the world right now that allows you to actually show a different display based on a different browser without actually having to touch the code. So the same code base can actually look different depending on the browser that you use. And some people might see that as a bug, but I see that as a feature. And I think it's really great, and we should be able to leverage this and turn it from a bug into a feature. So it makes web design so much more dynamic than any other medium that we have. Yeah.
Awesome. Awesome. I like an opinionated answer. That's great. Michael wants to know who is in charge of the spec for CSS. How does that work? Can you say?
There is a CSS working group. They are part of the W3C, and there are a number of editors who are in charge of sort of maintaining and updating the spec. And so Elika Atimat is one of them. Most people probably know her as Fantasy, and there are a number of other people, and all of them work together as a team under the CSS working group. And they do publish updates very often on the W3C CSS working group blog. They also have a Twitter account whereby they will post if they have updated any specifications. And specifications do follow a standard process of going from being a note to a working draft to a candidate recommendation and so on. It's all pretty interesting how things work on the web. And so each pillar of the web, which is HTML, CSS, and JavaScript, they have their own specs, so to speak. Like JavaScript has TC39. Those are the guys in charge of the JavaScript spec. So CSS has the CSS working group. And yeah, I don't think there's a one particular person in charge. So when you say who is, I'm going to assume that you're asking, like, is there a group? And the answer is yes, the CSS working group.
Cool, thank you. Yeah, and Jen Simmons, who is on the developer outreach team and a design advocate at Mozilla, and some of you have met and many of you have worked with at different points. She is also a participant in that working group. So she advocates for designers and the implementations that they are most passionate about. There's one more question on the Etherpad, and that's from Kalyan, who wants to know, from the developer's point of view, CSS always being a problem to work with, how does modern CSS help with that, since we have many libraries for the UI parts of the development work we do? And I have a feeling that Kalyan maybe joined a little bit after you started. I know I heard you say something about a whole Bootstrap library sitting in the code, but maybe you can pick it up from there. So.
Sure. So the reason why we have so many libraries for UI was precisely because it was kind of difficult to do, especially layout on the web in the past, because there was never a good, like a specific property for layout before CSS Grid. So I think most people are just tired of trying to clear floats or like trying to get their columns to show up in the right places. And a lot of the UI libraries do that for you. But if you look under the hood of those UI libraries, it's still CSS anyway. It's just that they've pre-written the CSS for you, so you just slap on classes into your markup and call it a day. But with the thing about such UI libraries is that they're very prescriptive. So unless your particular design looks exactly the same as the UI library, is formatted, odds are you'd want to you'd have to spend a lot of time trying to overwrite the styles that came with, and this just ends up being, a specificity war. I guess this is more apparent if you have your own product and you want your own, your own branding and your own look and feel. It makes more sense to actually come up with a UI library of your own for your own product, your own design. So modern CSS can help with that, because with CSS Grid, it's building a layout becomes a lot less painful than before. So the cost of actually having to sit down and write your layout code from scratch is much lower than the past, because in the past, I agree, it was a pain, it was a chore to just try to get the layout look exactly how you want it. But modern CSS will help. If we consider Grid and Flexbox modern CSS, then it definitely helps.
Awesome. So that kind of brings us down to the end of the Etherpad questions. I'm going to check one more time. We have a Telegram channel where folks hang out, and I think Michael's listening in to gather up any remaining questions. Michael, do anything else coming in from the channels, or anyone else on the call live?
I think we were able to hit on all the questions in the Etherpad and in Telegram. Great performance. I know it's pretty late in a lot of regions right now, so we might have a few additional questions come in via email and Telegram in the morning.
And
yeah, great.
And thank you for doing this before breakfast or with breakfast or first thing in the morning, your time. And this was like a Valentine's Day gift from you to the Tech Speakers program, even though I know it's like the day after.
Happy Valentine's Day, everybody.
So happy Valentine's Day to anyone who's still awake and celebrating. And, thank you so much for joining us. I'm going to go find a warm room.